Hello students, welcome once again to study more about filtration in the sixth session of the fourth unit under the particulate technology course. So, so this is the thing that you have studied in the previous class. The last session you learned about the leaf filter. So its general construction and working principles. Then we also learned the types of leaf filter and how they are constructed and operated along with the applications of leaf filter. So in today's class, let us discuss about the vacuum filters, their general principle and applications, and the advantages and disadvantages. And one important type of vacuum, continuous vacuum filter that is widely used in industry is the rotary drum filter. So we are supposed to learn today its construction, working, and applications. So what are vacuum filters? The filters in which the vacuum pressure acts as a driving force for filtration, that is to remove solids from suspension and liquid by applying a sub-atmospheric pressure on the downstream side of the filter medium, are called vacuum filters. So when the pressure that is acting on the downstream side of the filter medium is a sub-atmospheric pressure, that is the vacuum pressure, on the upstream side of the filter medium there will be atmospheric pressure acting on the filtering surface. So in that way, we can create a pressure difference or a pressure drop across the filter medium to act as a driving force to draw the filtrate through the filter medium, thereby separating the solids from liquids. So the vacuum filters are limited to maximum of 1 atmospheric pressure. So these filters now need a vacuum pump to create vacuum pressure on the downstream side of the filter medium to act as a driving force. So that is an additional thing is required for a vacuum filter. So coming to the different types of vacuum filters. So we have batch operated vacuum filters called the discontinuous vacuum filters. For example, nudged filter. So then we have continuous vacuum filters also. So as I told you, as an example, there is a rotary drum filter, which is a continuously operated vacuum filter. So before we take up rotary filter, let us go through the advantages and disadvantages of vacuum filters. So vacuum filters comparatively can be designed as an effective continuous filters. So that is the main advantage of vacuum filters. So since it is a continuous operation, so you need not require um, that much labor that is required for pressure pressure filters. So the labor requirement is low in this case. So the filtering surface, that is a surface on which the cake is getting deposited, is open to atmosphere. So because of this, the surface of the filtering medium is easily accessible for maintenance work such as inspection, repairing, etc. The maintenance costs are also less comparatively. So coming to disadvantages, we need a vacuum system here. That is an additional accessory required. So a vacuum system is involved in the operation, such as a vacuum pump. So that is also creating an additional maintenance. Okay, it cannot handle volatile filtrates. That is because so vacuum is a low pressure. So if the filtrate is volatile in nature, as soon as it is sucked into an environment where the low pressure is maintained, so it might tend to vaporize. So that causes a problem with the operation of the equipment. So due to that reason, we cannot handle the filtrates which are volatile in nature in a vacuum filter. Also, vacuum filters are not suitable for handling such type of solids which can form a compressible cake. So that is because when vacuum is applied initially, the solids will be tightly forced to press against the filter medium. So that solid, if it is having a tendency to form a compressible cake, then the initial layer of the cake that is formed will be tightly pressed on the filter medium to form a dense impermeable cake layer. So in that way, the rate of filtration gets affected. So it is not suitable for handling such kinds of solids where compressible cake is formed. So continuously operated vacuum filters are not that flexible in operation. So that is an added disadvantage of a vacuum filters. So as I told you already, the rotary drum filter is a continuous vacuum filter that is widely used in industrial operations. So this is the most common type of continuous vacuum filter. So it is the one filter in which the filtration, washing, partial drying, and discharge of the cake all are taking place simultaneously and automatically. So that is how we can adopt this one for a continuous vacuum, and that is filtration operation. So the filtration cycle, washing cycle, partial drying of the cake, and also the removal of the cake. So all takes place automatically in this type of filter. So coming to its construction, the rotary drum filter is as shown in this diagram, which in a simple manner shows the different parts of a rotary drum filter. It consists of a horizontal cylindrical sheet metal drum that is having a size of around 50 to 40 centimeter diameter and around 50 to 800 centimeter length. So depending upon the scale of the operation, you can construct with the different sizes. So it can be made in the size range of this and this centimeter and this much of length. The outer surface of the drum is formed out of a perforated plate. So here the outer surface is having perforations. The metal sheet what you are using to construct the outer surface of the drum will be having perforations, that is to suck the filtrate through that hole by applying vacuum from inside of the drum. So above that perforated plate surface, you will have a filter cloth such as a canvas cloth that is enveloping over the outer surface of the drum, acting as a filter medium. So the drum during the operation will revolve at a slower speed of zero point 0.1 to 2 revolutions per minute, and during that rotation, it continuously dips into a tank containing slurry that is to be subjected to filtration. Okay, so the slurry tank, which contains the slurry, so will be provided at the bottom of the drum, such that when the drum rotates, a small part of it, continuously dips inside the slurry. So this slurry tank, on one hand, is fitted with a blade called a doctor's blade. So this is meant for removing the cake once after every revolution of the drum. The slurry trough is also incorporated with a slow speed agitator in order to see that the solids are not settled out, and also to maintain the uniform concentration of the solids in the slurry. So inside the outer drum there is a small diameter drum, so that is having a solid surface. The annular space between the outer and the inner drum are divided into a number of partitions or the number of compartments by means of these radial partitions provided. So each compartment will be connected to a special rotary valve, so that will serve as a special kind of valve to remove the filtrate as well as the wash liquor from each drum. So as the drum rotates, the vacuum and air are admitted alternatively to each compartment. That is, so every compartment will pass specific locations during the operation. So when a compartment comes over here, it is acted upon by a vacuum from inside. So due to which the filtrate will enter through the compartment to the inside of the drum from where it can be removed as a filtrate. And when it comes to this position, it will be washed with the wash liquid, so which is also sucked inside the drum. And then after that, it will be subjected to drying by blowing the air. So either vacuum is applied to each compartment, or air is applied at various locations to carry out the filtration, washing, and drying cycles one after the other in series. So this is about the material of construction for a rotary drum filter. So the construction can be done with a suitable material depending upon the corrosive nature of the slurry that is being handled. So we can have a very corrosion resistant material like stainless steel, titanium, plastics such as PVC, etc. So that construction can be reduced by having a no corrosion, other low cost materials. So depending upon whether the slurry is corrosive or non-corrosive in nature. So this is how a rotary drum filter works. The drum is immersed to a certain depth in the slurry, which is mildly agitated to prevent the settling of the solids. So when the vacuum is applied, a portion to that portion of the drum which is submerged in the slurry through the rotary valve. Because of this, the liquid will be sucked into the compartment and the solid gets deposited on the cloth to form a cake of certain thickness, which can be regulated by adjusting the speed of the drum. See, whenever a portion of the drum, that is a compartment, dips inside the slurry, then the vacuum is applied by means of a specially designed rotary valve. So, due to that vacuum, the slurry will be attracted or forced towards the drum, and the solids gets deposited on the surface as cake, while the filtrate will be sucked to the inside of the drum. The thickness of the cake can be regulated by adjusting the speed of the drum. So with higher speeds, thinner cake will be formed. So you can have a high rate of filtration. If you reduce the speed of the drum, then a thick cake will be formed that will reduce the rate of filtration. So for a particular rate of filtration, you can adjust the speed and carry out the operation with that speed to get the desired thickness of the cake. The filtrate that is sucked inside the drum from each compartment then goes to a filtrate connecting tank through the internal pipe and the rotary valve. Okay, so this is how we can show the flow of filtrate. So this portion of the drum is inside the slurry. So then a vacuum is applied through this special designed valve called rotary valve. So then there is a pipe that is connecting the compartment to the rotary valve, and through that pipe the filtrate will be sucked and taken to that valve, and from there it is taken out of the drum to this filtrate collecting tank. So as the portion of the drum on which the cake is formed comes out of the slurry, the cake is washed by spraying the liquid. So this portion of the drum, when it comes out from this side, so will be having a certain thickness of cake on its surface. So that cake is subjected to washing when it comes to this position by means of these washer spray nozzles. The wash liquid will also be sucked by the vacuum acting from inside the drum. So there is another rotary valve that is meant for taking out the wash liquid from the drum. So after washing is over, then the drum comes to this position where air is blown from inside of the drum to dry the cake to as dry a condition as possible. So after the cake of solid has been spun dry, then the vacuum will be cut off. So then the cake is removed by scraping it off using a adjustable doctor's knife. So by the time the drum reaches this position, so it will come into contact with a doctor's knife that will scrap off all the deposited solids. In that way, cake dislodging takes place automatically. So again, after the removal of the cake from the surface of the drum, that surface is now free of any solids. Again, when it dips into the slurry, it will suck additional amount of filtrate along with the deposition of fresh thickness of cake. So this is another diagram showing you the parts and the working operation of the rotary drum filter. So this is a slurry trough and the drum that is rotating continuously dipping a portion of it inside the slurry that is to be filtered. So a cake thickness has formed here and it gets the washing cycle done at this position, then drying cycle when it comes to this position. Then by the time it comes here, the doctor's knife will have been adjusted to such a position that its sharp edge is cutting off all the deposited cake from the outer surface of the drum. So this is a point from which the filtrate is withdrawn and collected in this filtrate tank, which is connected to vacuum pump here. So this is how we can apply vacuum to the compartment which is being dipped inside the slurry taken inside in the slurry tank. So this pre-coat mix tank is for using the filtrate. So whenever the cake cannot be formed as a porous cake. So this is another diagram showing you the flow diagram for the working of a rotary drum filter. So this is a tank containing slurry. So that slurry from here is admitted to this trough and the rotating horizontal drum dips inside the trough, collects the solid on its surface before it sucks the liquid to the inside of the drum. Then the liquid that is sucked will be taken out from this outlet, taken to this collecting tank where it is stored, and because of by applying vacuum pump here can take out the slurry. So this is a one real picture of a rotary drum filter that is used in industries. Okay, so this is a doctor's knife that is performing cake dislodge operation. So here also one of the pictures showing you the outer surface of the drum. So you can see here that the outer surface of the drum is having perforations. So this is a rotary drum filter in operation in an industry. You can see how the cake is deposited on the outer surface and it is getting peeled off, scraped off. So this is another rotary filter drum in operation. One more rotary drum filter installed outdoors in a industry. Let us now discuss about the various advantages of rotary drum filter. It is entirely automatic in action, thus the labor requirement is very low. So cake consisting of coarse solids. Okay, so if the cake that is present in the slurry is consisting of coarse particles as a solids, then it is possible to remove most of the liquid from the cake before discharging. So if it is a fine solid, then removal of liquid from the cake may not occur that efficiently. So it has a large capacity for its size. So that means for a low space requirement, it can provide you large quantity of filtration. It is widely used for the filtration of large quantities of free flowing material. So by changing the speed, it's possible to build up cake of varying thickness. With fine solids, the thickness of the cake is small. So that is how we can decide the thickness of the cake depending upon which type of solid is to be removed here. So coming to disadvantages, the maximum available pressure difference is limited to less than atmospheric. So as it being a vacuum filter, a difficulty is encountered in filtration of hot liquids due to their tendency to boil. So as I said in the beginning, when we discussed the disadvantages of vacuum filter, so whenever the liquid that is being handled is hot and when it is volatile in nature, the application of vacuum may cause its vaporization. So there is a tendency to boil the hot liquids. So that is a drawback with the vacuum operated rotary filter. It is not suitable for handling materials that can form a impermeable cake. That is very dense cake if it is formed. Then such type of solids are not that suitably handled in a rotary drum filter. So they'll get tightly packed on the surface of the filter medium. So thereby it is not easy to remove such kind of filters from the cloth. So it is not suitable for filtering out the solids that can form a impermeable cake. So initial cost will be high due to the use of vacuum equipment. So all these are the drawbacks of the rotary drum filter. The speed of the rotary drum filter may be about dash RPM. Is it 1? Is it 50? Is it 100? Is it 500? So you all know that the drum in a rotary drum filter rotates at a slow speed. So the speed limit will be around 2 revolutions per minute. So 1 is the right answer because 50, 100 and 500 are too large. So that is so the right answer is answer A. So which of the following may prove unsuitable for filtering volatile liquids? Is it pressure filter? Is it gravity filter? Is it the centrifugal filter? Is it the vacuum filter? So vacuum filters are the most unsuitable type of filters for handling volatile liquids uh, because it may cause the volatile liquid to boil and vaporize during the operation. With increase in drum speed, the rotary drum filter in a rotary drum filter, the filtration rate increases, decrease, increases linearly, decreases, not affected. So with the increase in the speed of the drum, the cake thickness can be reduced. That way, we can increase the rate of filtration. Okay, uh, let me end the session with that.